Now here we will just go ahead and prove that the limit as x approaches 0 from the right, okay, of this function 1 plus x to power 1 over x is equal to e. Now the thing is this, if you go ahead and plug in 0 where x approaches 0, very little number from the right, that is 0.001, we go ahead and plug in such value in this, we're going to have 1 plus almost 0, okay, let's just say 1 plus 0 is 1 raised to the power of 1 divided by 0 is going to give us infinity. So at the end of the day, we're going to be left with 1 raised to the power infinity. What do you think that would be? So evaluating this limit would take us to a particular value, and that is e. So we want to prove that this is true using this limit right here. Now, we go ahead and do this, okay? So assuming we didn't know this to be e, okay, so the limit of this function should be equal to L. Let's call it L. Okay, so I want to make use of L'Hopital rule at some point. So to make use of that, I'm going to make this a fraction. So I'm going to make this a fraction by bringing this one down here. Okay, so I'm going to bring this one down here by taking the ln of both sides. So I'll go ahead and say that the limit as x approaches 0 plus, now we take the ln of both sides, we have ln of this man right here, 1 plus x is equal to the ln. Now after taking ln of both sides, I want you to note that from our basic log properties, that this man here will come down to this point. We're going to have the limit as x approaches 0 plus, okay, of 1 over x ln of the bracket right here, 1 plus x, okay, is equal to ln of L. Now, this can be written as over x, okay? It's the same thing right there. All right. Now, if we plug this value right here again, as x approaches 0, 1 plus 0 is just 1, okay? So ln of 1 is 0 over 0, that's indeterminate. So at this point, we can apply our L'Hopital's rule, which says that we should differentiate both the numerator and the denominator of the function with respect to x. So we're going to do that here, and we're going to have a derivative of this man, the derivative of the denominator right here. So we differentiate the numerator. Ln of this is just 1 over that, okay? 1 over 1 plus x divided by, now the derivative of x with respect to x is just going to give us 1. Okay, so still remember your ln L. All right, so if you bring this down, we're going to have 1 over, now this will come down right here, we have 1 plus x is equals to ln L. Now, if we now take the limit as x approaches 0, plus of this man right here, evaluating this limit, we're going to have 1 over 1 plus x. So as x approaches 0, 1 over 1 plus 0 is just 1. Okay, so this is equals to ln L. So we have here on the left hand side, 1 is equals to ln L. Now what is the limit? The limit was said to be equal to L. Okay, we have this to be equal to L. So that is to say, to find L, we need to take the exponent of both sides. That will become e to power, and know that from the log identity that this and this will cancel out. I'll be having e to power 1 is equal to L. That simply means that e is equal to the limit. Therefore, the limit of this function, 1 plus x raised to power 1 over x, as x approaches 0 from the right, is equal to L. That's what you get from evaluating the limit of this function, which would have given us the indeterminate power 1 to power infinity.